Hi. Now we are ready to discuss the IR obstacle detector. So this is the module. So it has 3 pins. Well, 4, but we are using 3 today. The 5-volt line, the ground line, and a digital output. The other pin which we will not be using today is an analog output. It has 2 bulbs over here, a transmitter, and a receiver. It has a calibration screw over here. This adjusts the sensitivity of the digital output. So the first thing I'm going to do is just connect 5 volts and ground. And I'm going to turn on the Arduino. Now, fair warning, before you start using this, just test the range of the calibration screw. What I mean is the physical range. Like this one turns from here till here. So this physical range is half a full rotation. So like 180 degrees. Just keep that in mind because I've successfully broken at least one or two, I think. Yeah, I've broken 1 or 2 of these by trying to twist the calibration screw beyond its limits. This also has 2 built-in LEDs. One is the power LED, which is glowing right now. The other is the digital output LED. So if I just adjust it, let's do it this way. Yes. I could make it more or less sensitive. So if I make it less sensitive over here, I have to go really close. If I make it more sensitive, yes. So this is how the IR obstacle detector works. And whatever is the output of that green LED, that is sent along the digital output line, the 3rd pin which we are using today. So basically how this IR sensor works is that the transmitter, it sends a burst of infrared out in front, and that gets reflected back to the detector. If the intensity crosses some value, the IR sensor detects that there is an obstacle and activates the digital out pin. And we adjust this sensitivity using this over here. Now there is one interesting feature of this IR sensor. It can not only be used to detect obstacles, but also black and white. So I have here a black tape. If I adjust the sensitivity accordingly, so if I hold it here in front of this white surface, it glows. Black, white, it glows. Black, nothing. That's because this black tape tends to absorb infrared radiation. As a result, this receiver end of the infrared sensor, it does not pick up any radiation, any significant intensity when in front of this black tape. It will be below the threshold which we have set by the calibration screw. So this is interesting. We can take the output, which is this green LED over here. We can take this output through digital out. So let me show you that. Right. So there is one interesting thing about the Arduino board. It has a built-in LED which corresponds to the state of pin 13. So what you can think of it as is an LED which is perpetually connected to pin 13. What this means is if you want to test whether you're receiving some output, you don't have to connect an external bulb or anything. All you can do is connect it to pin 13. So pin mode 13 output. We also need an input pin. Pin mode 12 input. You could use any one for the input. So basically my aim is to make an LED glow using the input from the IR sensor as its guide. The LED should glow when the IR sensor's LED glows. But instead of connecting an external LED, I can use the LED on Arduino Uno's board. So digital read pin 12. We need to set this to some variable. So int state. State is equal to digital read 12. Digital write 13 state. And let's do this at a very rapid interval. Let's ensure that this code is correct. Cool. Before I connect this, let's just make the additional connections we need. Right, I've connected that to pin 12. Now let's upload this. Observe that built-in LED. This LED right here near pin 13. That's it. Now you know how to use the IR sensor. We have discussed the motor. We have discussed LEDs and reading and writing to them. And with this, you're ready to make your line follower. Try to make the line follower using 3 IR sensors and 2 motors.